All right, 8-1 to 8-3 quiz is tomorrow. All right, this is for quarter 4. Everything we've done that says Q4 on it. Any homeworks that we've done that say HW4, this is all for the fourth quarter. Our fourth quarter is about to start, and it's going to go 100 miles an hour, especially for you seniors. You'll see it. All of a sudden, it's like the third quarter took forever, and then the fourth quarter is just gone. So just stay on top of things. Please try to be here on test and quiz days so you don't have a lot of makeups to do. On your quiz tomorrow, I'm going to repeat this probably 100 times, and somebody's going to come in here tomorrow and say, oh, I didn't know. Scientific calculator only. Scientific calculator only. Everybody with me? And understand, if you don't have one, borrow from somebody. Now, we're going to give you some formulas. You're going to have to memorize some formulas. The 2 formulas that you guys have to know, all right, you need to know these. You will not be given these, is the arithmetic, which is a sub n equals a sub 1 plus n minus 1 times d. Right? Everybody with me? Remember that one? The geometric one that you need to know, is a sub n equals a sub 1 times your common ratio to the n minus 1. All right, you guys have to know that. Remind me, what do we know about arithmetic? What is the d, the common difference? What is the d? It's another way we can look at that. It's the slope, right? It's the same as the slope. You're going to add or subtract the same thing to get from one term to the next. It's a linear function. In our geometric, our r is our common ratio. What is that going to be every single time? Something that you do what? Is it adding and subtracting? No, it's multiplying, okay? And if your number is getting smaller, then you're multiplying by a what? A fraction. Okay, good. All right, how do you find the common? If you're given a whole bunch of terms in a sequence, to find the common ratio, just take a term and divide it by the 1 in front of it. Doesn't matter. A sub 3 divided by a sub 2. A sub 7 divided by a sub 6. That doesn't matter. But you guys have to know those 2 formulas. We're not going to give those to you. On the test, we're going to give you the sum ones. So the sum formulas. For the arithmetic sum, the formula is S sub n equals n over 2 times a sub 1 plus the last term, a sub n. We're going to give this to you. It's going to be on your quiz. This is given. Then you have, there's 2 geometric. There's one for a finite, and there's one for an infinite. Yes? Okay, so we're going to give those to you as well. What's the finite one? You guys should have your answers open. You should be looking at it. What's the finite formula? The one that ends. Everybody look at it. Okay, so a sub n equals, say it again, first term times okay, and then your finite, the one, or infinite, I'm sorry. What's the infinite one? 1 minus r. Okay, good. Now, if the wording of the direction says exact, if it says exact, what does that mean? If they want an exact value. No decimals, okay? If it comes out to be 0.25, something like that, a terminating decimal, fine. But if you get a fraction, guys, if you get a decimal in your calculator, it's one of those crazy irrational repeating decimals, you have to keep your answer in a fraction. We're going to take off points for that. So make sure, if you leave it as a decimal, it's an exact, it's a terminating one. It's not one that you have, what am I trying to say? Rounded. Oh my gosh. Whew. Okay, so let's go through some problems. You guys need to know how to find the first terms of something, inputting numbers, that sort of thing. So a question like this. If it said to find the first three terms, assuming the first start n equals 1, you would plug in what? What three numbers? 1, 2, and 3, okay? So in a question like this, they're not asking for the first term, they're asking for which one? The 16th term. Let me show you how you have to answer questions in order to get full credit. Not a sub n equal, a sub 16 equals whatever the answer is. I need to see that you guys say, okay, I know that I'm going to put in 16 here because that's the term number, squared, and then 4 times 16 minus 3. That is enough work for me. If you want to show me the simplification throughout, that's totally fine. But I have to see what you put in your calculator. I actually put that in the directions. So as we simplify this, guys, what is 16 squared? 16 squared? 256, okay. Over, what's 16 times 4? 64 minus 3. Okay, so it's 256 over 61. Divide that in your calculator. What is 256 divided by 61? What kind of a decimal is it? It's terminating. What is it? It's non-terminating. It's like blah, 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 right? So this would be your exact answer. If you give me a decimal equivalent and it's not a terminating decimal, you're getting points off. But I have to see that part. I've got to see you guys showing me what you're evaluating. Does that make sense? Everybody understand? Okay, scooting along. I want to make sure I hit every type of question. All right, write an expression for the apparent. Sometimes they'll tell you, hey, this is an arithmetic, so you know, or this is geometric. Sometimes you have to figure it out. Guys, there's only two types that you're going to see on this quiz to write rules for. It's either where you add or subtract the same thing every time, or where you multiply. I'm not going to give you a crazy one that you guys have to just figure out the pattern. So look at this. From -3 to -8 to -13 to -18. What are we doing every single time? You're doing what? Subtracting 5. Perfect. -5 minus 5. So that would be your common difference. -5. Now, there's two ways I showed you to do this. You can now say that a sub 1 is -3, right? And then plug it into the formula. A sub n equals -3 plus n minus 1 times -5. So we have -3 minus 5n plus 5. You guys agree? And then a sub n equals -5n plus 2. There's your rule. That's perfectly fine. The other way to do it is to think of this as xy, right? This is your first term, your second term, your third term, your fourth term. So if you find the 0 term, aren't you finding the y-intercept where it crosses the axis? How would you get from -3 to the term before it? Instead of subtracting 5 each time, you would do what? You would add 5. So -3 plus 5 is 2, which is right there, your intercept. Either way you do that is fine, just as long as you show me. Do you see? This is a tiny little bit of work right here to show me, oh, I see what they did. They went backwards, right? You found the 0 term. That's fine. Now, once you find that, if you were asked to find the 175th term, then you just do what? Plug in 175. All right, now yes?
I was going to say for the second one, I couldn't tell if it was geometric or arithmetic, so I divided by the previous term. I think I did something wrong. All
right, well, let's look at it. Hang on. All right, let's look at this one. I tell you tomorrow on your quiz, everything will work out. I'm not 100% sure. I think it actually says find the geometric rule or whatever. I think I wrote that in there. But if it doesn't, and for some reason you get one and it's not adding or subtracting the same thing, and it's not dividing or multiplying, I'm sorry, then you're not going to be able to write a rule for it. But like Cassie just said, guys, a lot of times when you have fractions, it's hard to tell what's going on. So my suggestion would be one of two things. First of all, I see 3 fractions and a whole number, yeah? Can you change 1 to a fraction that has a 2 as a denominator? What would you change it to? 2 over 2? Okay, I think that would be easier to do just because now they all have the same denominator, correct? Now, if you think this is geometric, God bless you. Just like Cassie said, you would take the second term and divide it by the first. The third term divided by whatever. So I'm going to say 5 over 2 divided by 2 over 2. So when I do that, I keep, change, and then flip, right? So this becomes 5 over 2. All right, so let's see if this is true throughout. So 7 over 2 divided by 5 over 2. Keep, change, and then I flip. 7 over 5. Is this a geometric? No. How do you know? This isn't the same number. What's another way you could tell from the beginning that this is not geometric? What did I tell you guys about signs with geometric? It would alternate, right? If you had a negative here, then every other would be negative because you're multiplying. So now let's look and say, okay, well, how did I get from negative 1 to positive 2? Since they all have the same denominator, I don't really have to think about that. But how did I get from negative 1 to positive 2? I'd have to add how much? So plus 3. How would I get from 2 to 5? Plus 3. How would I get from 5 to 7? Plus 2. All right, so the way that this is written, it doesn't fall into either category. But just say this was an 8. What would this be? Plus 3. All right, let's do this problem as if it were that. You're adding the same every time. So what is your common difference in this case? Your common difference is what? It's not 3. It's 3 over 2. I just didn't use the denominator as I was thinking because it was all the same. So your first term is negative 1/2. A lot of times, guys, with fractions, it's easier to use this given formula that you guys first learned rather than finding the zero term, just because you guys don't like to work with fractions. But if you were to plug this in, so a sub n equals, my first term is negative 1/2 plus, I have n minus 1 times 3/2. So I have negative 1/2 plus, when I distribute, I have 3 over 2n minus 3 over 2, correct? You guys with me? So I have a sub n equals 3 over 2n. What's a negative half and a negative 3/2? Negative 4/2, which is minus what? Minus 2. Could you leave it as negative 4 over 2? I'd rather you not. Now, how do you know, once you write this rule, how do you know, how could you check it? If I plugged in a 4, right, with this new thing that I just changed it to, when I plug in 4 for n, what should my answer be? 8 over 2. Every time you guys write the rule, you can always go back and check with the given information to see, oh, okay, it makes sense. I did not put any, I'm telling you again, I did not put any on the quiz tomorrow that I gave you a sequence, and it is not either arithmetic or geometric. I did not give you one like that. Very straightforward quiz tomorrow, I promise. Question so far? Yes?
Isn't that different, like the 2 over the 3, because we converted like the whole number 1 to 2 over 2, right?
Okay, let's scoot along. I made up a problem on the bottom here. All right, you're going to have a factorial one. Guys, this is super simple, super basic, but I do need to see a little bit of work. What does this mean? We're just super excited for 12 and 5? Yeah, you guys don't like my joke. Come on. All right, so what this means, 12 times everything below it. So 11 times what? 10 times 9 times 8 times. Can I stop right there? Why? Because there's a 7 factorial on the bottom, isn't there? All right, so then there's another number with an exclamation point. That doesn't mean I just multiply all that stuff by 5. What does that mean? 5 times 4. Can I stop at 4? How come? Because there's a 4 on the bottom. Now, if you guys did not do that, that's totally fine. Write them all out. But anything that is on top and bottom exactly the same, you can cross out, and then you can cross cancel, or you can cancel top and bottom. So if you wrote out 7, 6, 5, 4, 3, 2, 1 on the top, you could write it on the bottom and cross them out. Same thing with the 4s. But notice the 4 and the 7 in the denominator are separate. That is not 4 times 7 factorial. It's 2 different things. So these 2 cancel, correct? And then what do you have here? 12 times 11 times 10 times 9 times 8 times 5. A ginormous number in your calculator. Does it work out to be a pretty number, or is it times 10 to the something? It's a pretty number? Okay. What is it? 475. 200? Oh, that's it? Oh. Now, tomorrow on your quiz, you are not going to get something that is times 10 to the 12th or anything like that. I made sure the numbers were there. Some of them are large. You might have 12 numbers in it, but it's not times 10 or anything in scientific notation. So if you get that, you miss something. But make sure you guys know how to do a factorial. Yes?
So for the factorials, the number underneath it, that can go with either one. It doesn't have to be like...
Nope. As long as anything on the top can cross off with anything on the bottom. Good question. Like, you can't say 12 divided by 4 is 3 factorial. That's not a true statement. All right, so make sure you guys understand that. You cannot say that 12 times 5 is 60 factorial. Not a true statement. Those are two independent things. All right, I want to do a question like this because the sum ones are easy when you start with 1 and you end with 6. On your quiz, you're going to have something similar to this for geometric and for arithmetic. So I want you guys to see this. First thing I want you to do is write down bottom just kidding. Top minus bottom plus 1. You will be given this formula. The formula to find the sum is S sub n equals the number of terms over 2 times a sub 1 plus the last term, a sub n. So now think about this, guys. What this question is saying is to evaluate this. I changed it, so change it with me. You're going to start with 5 and end with 59, plugging in for I, correct? Now, could you plug in 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way to 59 into that expression and then add them all together? Yes. Will you have enough time to do that tomorrow? No. So you're going to have to use the formula. The end part, the 3 things you need is you need to know how many terms there are, you need to know the first term, and you need to know the last term. In this case, it's a sub 59. You have all of the information you need. This is the thing that is sometimes catches us. How many terms are there between 5 and 59? Well, this little formula right here will give you the correct answer every time. A lot of you are like, well, do I include 5? Do I include 59? The way that you figure out how many terms total there are is you take the top number minus the bottom. So I have 59 minus 5, and then I do what? Add 1. Every single time, that'll tell you the total. So what's 59 minus 5? 54 plus 1 is 55. In between 5 and 59, there's actually 55 terms because 5 is included and so is 59. So anytime you guys have a sum, whether it's geometric or arithmetic, and it's a big gap, just say top minus the bottom and then add 1. All right, so how do I figure out what the first term of this is? It's not, I'm going to plug in 5, right? I'm going to plug in 5 because that's where my sequence is starting. But I have to figure out what that value is. It's not 5. It's what is the value when I plug in 5. So it's 8 times 5 minus 5. What's 8 times 5? 40. And 40 minus 5 is 35. Okay. And then the last term, well, that would be the 59th term. So I'm going to plug in 59. So 8 times 59 minus 5. What's 8 times 59? 472 minus 5 is 467. So now, guys, look, you really don't have to think on this problem because we're giving you the formula. You just have to find all the information to stick it into different spots. So I'm going to plug in right here 55 over 2 times, what is the 5th term? 35 plus, what is the 59th term? 467. So let's simplify first. What's 55 divided by 2? You can do it on the outside. It's a decimal, but it terminates. What's 55 divided by 2? Say it again. 27. Okay, 27.5. Thank you. And then what's 35 plus 467? One more time.
502.
502. Thank you. And then multiply those two together. It's 27.5 times 502. One more time. 13,805 flat. Okay, perfect. All right, now on a question like this, guys, you might get a huge number. 13,364,274,003. That's okay. If it takes up your whole calculator display, that's okay. It's just not going to be times 10 to the whatever. All right, questions about that?
This is the one where you do like they have to find the R2, right?
No, that's the geometric.
So it just says find the sum. That's what we use.
Yeah, you're going to use the arithmetic sum. All right, let's take this question. I just made this up. We did a question like this in the notes, but I want to do a question like this. I want you to find the a sub 93. All right, we're trying to find the 93rd term. We're given two terms. Now, guys, remember, arithmetic. When I think of arithmetic, I think common difference. And I also think of the word what? Slope. Because you're adding or subtracting at the same time. So all of the information you need in order to write the rule and find the missing term is right here in front of you. What is the ordered pair that's associated right here? 4, comma, negative 9. What's the ordered pair here? 10, negative 33. You guys had a problem like this on WebAssign. I had 2 people ask me questions about it. Just because we don't go over something explicitly, you guys need to be familiar with it. So if you encounter something that you don't know how to do on WebAssign, you need to ask about it. So if I'm going to find the common difference, guys, my slope, I'm going to say negative 33 minus a negative 9, so plus 9. You guys with me? And then I have 10 minus 4. Could you have gone the other way? Absolutely. But what's negative 33 plus 9? Negative 24 over what's 10 minus 4? 6. So what's your common difference? Negative 4. All right. I need 2 things in order to write my rule. I need my common difference and I need my first term. How you go about finding the first term is up to you guys. Could you write out an XY chart and say, okay, well, the 4th term is negative 9, so then I'm going to go backwards and add 4, add 4, add 4, add 4? Sure. If you don't want to do that, say it's too far away, then let's do this, all right? Your rule is a sub n equals a sub 1 plus n minus 1 times d. Well, think about the information you have. Do you know one of the term numbers? You know the 4th term and you know the 10th term, right? So you could say, all right, well, I'm going to, instead of a sub n, I'm going to put in the 4th term, negative 9. I'm trying to find the first term. Well, what's the term number that we're using? The 4th. Okay, so I'm going to say 4 minus 1 times, what's the common difference? Negative 4. You guys can do that if you want. You could also use the 10th term. The 10th term is negative 33. So instead of 4, you would have plugged in 10. It would have been fine. But now you just use algebra. So negative 9 equals, there's lots of a's that start to look like 9s. A sub 1. What's 4 minus 1? 4 minus 1 is 3. And then 3 times negative 4 is negative 12. You guys agree? All right, so now what do? Add 12 to both sides. So the first term is what? Positive 3. Okay, now do you have the 2 things you need in order to write a rule? So a sub n equals negative 3 plus n minus 1 times negative 4. Well, isn't the common difference negative 4? Right? Isn't our common difference negative 4? Yes? Oh, I put negative? My bad. I thought you said the common difference. I'm sorry. Yeah. All right, so I have 3 and then negative 4n plus 4. You guys agree? Okay, so negative 4n plus 7. That's my rule. Have I answered this darn question yet? No. What was the question I asked at the beginning? What's the 93rd term? So we have to do all of that work to figure out what the rule is. So I'm going to say, okay, the 93rd term is negative 4 times 93 plus 7. What's negative 4 times 93? How much? Negative 372. Okay. And then I'm going to add 7 to it. And I get negative 365. There is your answer. But all of that work needs to go with it. Now, if you did not do this part, and you just, in your mind, went backwards, that's fine. As long as you show me, set up a little chart that you're like, okay, I know the fourth term was this, so I went back and I went back and I went back and I went back. That's fine. That's problem solving. I'm okay with that. Do you guys understand? You're with me? Okay, let's scoot. Everything on this page is pretty straightforward. I worked it out in the review, so if you guys have questions about this page, when I'm done here, you can ask me, but this is pretty straightforward. I just want to make sure I got to the ones that were a little iffy for you. Arithmetic. Okay, let's go here to some geometric stuff. All right, if I'm going to write the rule for this geometric, again, you guys have to know this one. So geometric would be what? A sub 1 times r to the n minus 1, correct? So the rule would look like what? 3 times r is 1/5 to the n minus 1. And then if you guys were asked to find the first 3 terms, you'd plug in what numbers for n? Right? 1, 2, and 3, right? Okay. What's the rule for this one? Write it for me. Seven times -2 to the n minus 1. And then how would you find the fourth term? Okay, plug in 4. What's the common difference here? How'd I get from here to here to here to here to here? Times 2, times 2, times 2. Now, if you did not see that, you could take 48 divided by 24. You get 2. You take 24 divided by 12. You get 2, right? All right, so writing the rule should be pretty simple here. Let's find the sum of the first 13 geometric. Now, we're going to give you the sum formulas, correct? I'm going to give you the sum formula. What do you notice about this geometric sequence? Is it infinite or is it finite? Does it end or does it stop? What do those 3 numbers mean? It continues. It keeps going. All right. So in order to, and again, you guys will be given the formulas, but what is the infinite sum formula? It's a sub 1 over what? 1 minus r. So again, you still need to know all the stuff. You just got to figure out what goes where. So what is your first term here? 5 over 1 minus, what is the common ratio? -15 divided by 5 is -3. What's 45 divided by -15? -3. Okay, so it's 1 minus -3, correct? So this becomes 5 over what? 4. That's it. Now you guys are thinking, you're like, how in the world could that be the answer? Well, think about this, guys. What does the word sum mean? The total when you do what? Add. So if you're thinking about it, if you're adding a positive and then a negative and then a positive and a negative and then a positive and a negative, it's not going to be a huge number because what you're adding, you're then taking away 3 times that amount. Then you're adding 3 times, then you're taking away. So when you have the sum of an infinite series, it's generally not a huge number like when you have an arithmetic one. Because you're multiplying, you're adding and then pretty much subtracting with the alternating signs. Do you guys see that? Does that make sense? Don't get tripped up on that. If you have a question like this, all right, I'm going to change this one a little bit. I'm going to start with I is 7. And our last term here is, I don't want this to get too crazy. So 29. Okay, so you have what this means is you're going to plug in, you're going to start with 7 and end with what? 29. They're going to add them all together. But we're not going to do that because that's going to take too long. How do you figure out the total number of numbers that would be in this sequence? 29 minus 7, what? Plus 1, okay? How would you figure out? Think about what you need. What do you need in order to find the sum of a geometric sequence, the finite one? What's the formula for finite? First term. Then what? 1 minus r to the n power over what? 1 minus r. Okay, so relax, guys, for a second. There's some things we need. We need our n. We need our r. And we need our first term, correct? Well, what is the n? How did I figure that out? It's bottom minus top. So 29 minus 7 is 22 plus 1 is 23. So there's 23 terms we're talking about. What is your r? What is happening each time? It's 4. Good. And then how do you find the first term? You plug in 7 because the first term we're looking at is 7. So when I plug in 7, this is going to be huge. 2 times 4 to the, okay, what's 4 to the 7th power? 16, 384. Okay, times that by 2. 6, 327, 6, 0, 6, 8. Yeah?
32768.
Gotcha. 32,768. Gotcha. All right, then let's just plug in everything else. So I have 1 minus, what was our r again? 4 to what power? 23rd power. And then I have 1 minus what on the bottom? Okay, obviously this is going to be a ridiculous number. You guys agree with me? Okay, but do you understand the makings of this? The biggest thing, guys, the biggest thing is finding out the n. And remember, it's bottom minus top plus 1. That's how you figure out what that n is. Again, this will be probably a really big number in your calculator because you're starting with a specific number, you're ending with a specific one, and you're adding them all together. This will probably be a big number, but it's not going to be like, this is a poor example on my part, it's not going to be, you know, like I said, 10 times whatever to the whatever power. It's not going to be like that.
How do we plug it into the calculator? Which part do we plug first?
Inside out. I would, that's a good question. So if I were going to do this in the calculator, I'd have 32,768 out here. Obviously 1 minus 4 is negative 3. So I would do this part of your numerator first. I would say 1 minus 4 to the 23rd power. Get that? Then divided by negative 3, then multiply to the outside. Or like if this cross canceled here, you could cancel, you know, there's some ways to cancel it out a little bit throughout, but. All right, last type I want to go over. This is geometric. It'll say given the geometric. All right, so when I see geometric, I say, oh, okay, I need a sub 1 times r to the n minus 1. That's the rule. All right, I want to find the first term. I have 2 terms here, but I can't just find the slope. I can't say that it's 3 comma 5 and 8 comma negative 1 over 625 because your common ratio is not the same every time. So we did a problem like this on the notes. I also started off the second video with this as well. Does anybody remember what we did? Okay, let's use the information that we have. I know the 8th term, a sub 8, and I know a sub n. Just kidding. I know a sub 3 times r. How many spaces away are 8 and 3? 5 spaces. That's going to be my exponent here. We're not plugging into this formula here. We're trying. If they were right next to each other, we could just divide the preceding, the third divided by the second, third divided by the fourth divided by third, whatever. But we can't. So your exponent becomes the spaces away. So now I say, okay, I have 1 over 625 equals 5 times r to the 5th power. How do I get r all by itself? Divide both sides by, so divide by 5 over 1, right? You guys agree? So I have 1 over 625 times 1/5. What's 625 times 5? One more time, Ava, I'm sorry. 3,125? Okay, so I have 1 over 3,125. How do I get r by itself? I take the fifth root, right? Now, since this is an odd root, it could be plus or minus. We're just going to assume all are positive because they didn't give you one negative, one positive. So I have R equals, what is 3,125th? What's the fifth root of that? Actually, because it's positive, you're taking the fifth root, it's going to be a positive answer, but bless you. What times itself 5 times gives you 3125? 5, okay. So your common ratio is 1/5. You use the given terms that they give you. Your exponent becomes the spaces away, we'll call it. So I know that R is 1/5. Okay, perfect. Now I have to figure out what the first term is. I can use that same exact process. It doesn't matter which number you use. I'm going to use the third term. I'm going to say A sub 3 equals A sub 1 times R to the spaces away. I know the third term is 5. I don't know what A sub 1 is. I do know my common ratio is what? What's my common ratio? 1/5. And then how many spaces away is the third term from the first term? It's 2 spaces away. And then we just simplify. So I have 5 equals A sub 1 times 1/25. You guys could have done the exact same thing with the 8th term. Your numbers just would have been a little different. But you have a calculator, so it doesn't really matter. So how do I get A sub 1 by itself? I'm going to multiply both sides by 25, correct? So the first term happens to be what number? What's 25 times 5? 125. Good. So now you have the first term. Now you have the common ratio. So you guys can write your rule. It's my first term, which is 125 times my R to the n minus 1. Now, if you were asked to find the 15th term, you would plug in 15. And again, it's going to say exact, meaning if you don't get a terminating decimal, you've got to leave it in fraction form. Questions? Nothing tricky, guys. Very straightforward. We're going to give you the arithmetic and the geometric sum formulas. You just have to know how to write the rule for an arithmetic or a geometric sequence. But we're going to give you the sum formulas. Make it a little easier. Sound good?